Hello, everyone. Welcome to episode 128 of the J Situation Podcast. I'm recording this on August 30th, 2022. I'm back at it this week. That's right. How are you guys doing? Man, I hope you all have had a wonderful start to your week. And on this Wednesday, or late Tuesday, if you're one of those time travelers, I hope you're all well on your way to a productive week, or at least an enjoyable week. You know, at least one of those two things. A lot going on at PEW Science right now. Some shooting, some testing, and hey, even some more data and analysis publications coming. So that's really cool. In fact, you'll get some more data this week. You will. I'll talk about that on today's episode. Also, I'm very excited and pleased to announce a new sponsor of this podcast. That's right. This episode is brought to you by the fine folks at High-End Armament Technology. That's right. High-End Armament Technology is a dealer of exactly that. They are high-end arms. High-end arms and accessories. You know, I recently came to know Mr. Robert Lewis and his organization. Robert and High-End Armament has significant longevity in the machine gun and NFA game, as well as significant expertise in both the procurement and operation of those wares, okay? And also night vision, thermal optics, infrared sighting systems. Really a lot of really great stuff. And guys, I think it's important to note, for sponsors, I am very careful who I associate with. Okay? PEW Science members and listeners to this podcast have come to expect a certain level of quality in the information that I distribute. Right? I mean, I think we can all agree on that. I think I understand your expectations. So one thing that I've thought that there is lacking is the general public knowledge of a dealer that can not only get you what you need when you need it, but that has the expertise to understand the weapons and the apparatus. Okay, that's really what I'm going for here, and what I'm really excited about, you know, when I'm telling you about high-end armament. So, you know, I can't tell you how many times I've heard horror stories about buying a transferable machine gun, or a thermal weapon sight, or you know, a night vision gadget, or some other item that might be of significant cost, right? It might be a significant cost to you. You know, I've heard these horror stories of this is how you go buy something like that, and you know, maybe the buyer gets a runaround or gets misled by the dealer. You know, that's not good. That's not something that should happen at all. And I have a very low tolerance for things like that. Okay, so I'm really not. That's not my cup of tea. I can tell you right now that interfacing with high-end armament is refreshing. It really is. Robert and his crew, they have decades of experience in actual knowledge of the gear. Okay, actual knowledge. So big thanks to them for supporting this podcast. It's greatly appreciated. Check them out at highendarms.com on the web there. You can check them out on Instagram at highendarms, and they even have a Facebook page, which is also High-End Arms. That's right. I hope they can help you folks out if you need it. And if you do, if you go check them out and you ask them for something, tell them Jay sent you, and I think they'll take good care of you. Okay, please let me know your experience. I really think it's important. You know, it's awesome that they're sponsoring the podcast, but most importantly, it's awesome that I get to tell people about this resource. Like, I mean, since I started doing this podcast, this is the 128th episode. Guys, it's been for a couple of years now. I have had quite a lot of you message me or email me and be like, man, Jay, I want to buy a machine gun, but where's a good place? Or I want to buy this and that. Well, do you know, like, who is not going to rip me off? Or, hey, I'm trying to find this. It's a really hard gun to find. Do you know where I can find XYZ? All of those questions, I feel like I can answer now. And I can just be like, hey, just call Robert at High-End Arms. Just call High-End Armament Technology, and he'll take care of you. And I think that's a good statement. So That's the idea of this, and I hope it works. Okay, that's right. And also, as always, the J Situation podcast is sponsored by Silencer Shop. That's right. You can use their kiosk. You can do your fingerprints and photos electronically. And in turn, you cut down on errors. You simplify your silencer purchasing process. You get a money-back guarantee. It's great. No transfer fees. No paperwork errors. Just you and your silencer with no drama. It truly is silencer ownership simplified. That's right. And if you guys are buying ammo, I do have a coupon code there on the website. It's for True Shot Gun Club out of Arizona. You can click the link in the show notes or on the website there, pewscience.com/podcast. For every episode, it takes you to their site. If you buy ammo using that link, it helps the podcast. It helps Pew Science. And if you want to join their A-Zone membership to get free shipping on all the ammo for a year, use code word Pew Science. You get $20 off that membership. That's right. You win, they win. You help the podcast. Okay. And finally, most importantly, the J Situation podcast is sponsored by Pew Science, pushing the silencer industry forward one test at a time. That's right. Visit pewscience.com for the suppression rating, the simplest and the most accurate hearing safe ratings for your suppressed small arms based on true human inner ear response from the entire gunshot from before combustion takes place all the way until all the combustion is gone. That's right. The entire thing the weapon is doing, that's what we're capturing. The suppression rating is in Section 5 of the Silencer Sound Standard. There are also reviews in Section 6 of the standard. And finally, Section 7 contains the rankings. It's a simple database tool with which you can sort and filter all public test results. When you find something you like, click the links in the table and it'll take you back to Section 6 where you can look at the most in-depth silencer data in the world. You can. And as always, if you're a manufacturer and you would like to use Pew Science for private testing and consulting services, there's a form on the website with which you can submit that inquiry. Your contact information and all test data will be held in strict confidence, unless you want to release it to the public, in which case Pew Science can help you do that. And guess what? Guess what's happening very soon? Oh my gosh, you might get some of that again. It is, what a time to be a silencer consumer right now. You're living in the golden age. You might not even know it. It's crazy. You can support this podcast. You can support Pew Science. You can support all the testing I do by joining with a membership at pewscience.com. It's awesome. Also, if you want to give more or less, there's a donate feature on the review page and the podcast page. Every little bit helps. And, something that's free, doesn't cost you anything. You can go ahead and give this podcast a good rating on iTunes or Spotify and any of your podcast providers there. It helps folks know that silencers and guns are awesome. Maybe we can normalize the use of suppressed small arms. That is the goal. That's right. Okay. I have 4 topics prepared for you today. There's a lot to talk about. It might get long. I'm not sure. Topic 1, SCAR update number 7. Using the Mototech SCARburator to tune the weapon. That's right. Tune the weapon for suppressed use. I'm going to talk about some things to consider, give you some overall glimpse of that system. So this will be your Pew Science SCAR update number 7. Or rather the Pew Science SCAR Project update number 7. Topic 2, new sound signature today. New sound signature review this week. This week? This week? Yes, this week. Oh, yes. I am excited. Boy, howdy, am I excited. Big things. Disruptive things. Buckle up for that. Topic 3, thermal sights and you. How to spend more money than you thought you would and not be completely upset necessarily. That's right. And topic 4, thanks for your support. I do mean it. Direct feedback indicates Pew Science is doing some good. So that's awesome. Your support fuels the effort. It really does. And members are gracious and tenacious. And how's that for a rhyme for you? Okay. He's got jokes. Let's move into topic 1 at a time in 9 minutes and 32 seconds. All right. I got a little bit long-winded on that. But also, I had to introduce Robert and high-end armament technology to you guys. You guys probably, some of you actually do know him, and you do know that dealer and that organization. But some people might not. So I feel like, let me introduce him properly, and it'll be great. Okay. And I hope you guys really need, I mean, I know it's an ad and I know they're sponsoring the podcast, but I'm telling you, I wouldn't be reading it if I didn't think it would benefit you. Seriously, like if you're in the market for stuff that you, like if you think of a gun that you want and like you're like, I don't know where to find one of those, call that dude, man. Trust me. All right, topic 1, PEW Science SCAR Project, update number 7. Using the Mototech SCARburator to tune the weapon for suppressed use. Okay, these are some things to consider. I'm gonna give you an overall picture here. So, one thing that sucks, kinda, I hate that it's been almost a couple of weeks now since I used this. Okay, because I might not remember every single nuance, but I'm gonna do my best to recall it. Okay, I've been so busy and we were so busy last episode with what we were talking about. I couldn't fit this in. So we kind of got pushed, 1 second. Excuse me. We kind of got pushed and I couldn't fit it in the last episode. So we're doing it now. If you've been following the PEW Science SCAR Project, and this is a little recap for you, I acquired a SCAR 17 weapon system in order to study the effects of silencer flow restriction. Okay, I bought this at retail. All right, guys, just so you guys know, for those of you just tuning in, this isn't some operation where everything gets given to Jay for free to just play all day. No, almost everything I receive for evaluation is stuff I buy so that I can properly characterize it, and it stays in the PEW Science. Basically, PEW Science library is what I call it. The PEW Science inventory is a library, and it stays there for characterization. Now, the SCAR is a particularly useful tool for this, for studying the effects of silencer flow restriction, because it's extremely gas sensitive. All right, if you read the articles on pewscience.com, or more specifically, if you look at Table 3 of Public Research Supplement 640, or if you look at Table 2 of many of the 308 silencer reviews on a bolt gun, you're going to see the term gas sensitive used. Okay, that's a term I use in the articles I write. I use the term gas sensitive. Now, I didn't invent the words, but I was the first to apply them to this area of study in this way. And so I define gas sensitivity as the likelihood of flow restriction influencing the operation of a suppressed weapon system. Okay, so the reason gas sensitivity exists and the reason it's tied to flow restriction of a silencer is because adding a silencer to a weapon increases the dwell. All right, the duration of pressure in the barrel after combustion takes place. Okay. Like normally in a small arm, the combustion gases vent out of the muzzle at a given rate. All right, so reciprocating weapon systems are designed in accordance with a certain blowdown rate. Okay, that's how they're designed. Now, adding a silencer decreases that blowdown rate significantly. Okay, as a result, the duration of positive pressure in the barrel and in the chamber increases. And when that pressure is above a certain level, right, and other components of the system are moving, like, for example, during bolt unlock, after bolt unlock, during reciprocation, when these things are moving during this continuous positive phase pressure inside the system, you might have adverse consequences. Okay, because you're moving outside the design envelope of the weapon system. Okay, so in the case of the SCAR, it is particularly sensitive. It's like an AR in a way, in that the weapon may overfunction. Okay, it may overfunction due to excess pressure being present after bolt unlock. Okay, this is possible, like in an AR, but the SCAR has different geometry in its carrier and different kinematics in the bolt and carrier assembly and the way they move. So without getting too technical and without violating an NDA, I can tell you that the SCAR does not like to like when there's too much flow restriction, okay? It just doesn't like it. So how much is safe? Okay. How much flow restriction is safe? And if you know that amount for the SCAR, how would you quantify it? And if you did, if you quantified this, is it a universal quantification that can be used by everyone? Like, is it directly tied to the omega metric? Okay, so these are some of the questions the PEW Science SCAR project may answer for us. Okay, this is part of the research directions, part of the goals. Now, I had restricted the gas orifice. I changed the adjustment screw in the SCAR 17 and used an OSS silencer, right? If you've been following along. And two things, these two things were done, okay, let me say it this way. These two things were intended to reduce the amount of gas impulse seen by the piston, and in turn, allow me to shoot the rifle with softer recoil and no overfunction. Okay. It made the rifle a joy to shoot, really. Actually, the SCAR 17 has become my favorite rifle. It has become my favorite rifle. One second. Excuse me. It really has. Hands down, really. I love it. I love that thing. I love it so much that I have spent a lot of money for optics and other things for the rifle, and I actually do consider it to be one of the best dual utility rifles in existence with its 13-inch barrel. Okay, for my use case, it can do most things I need it to and do it pretty well. So, in a quest to continue the SCAR project, knowing that I now have more than purely academic interest in the rifle, right? Say I've gotten familiar with it, right? Remember I told you that? How I was like, I'm going to get familiar with this system. I'm going to get all up in the SCAR. Remember I told you that? I think I used those words, probably did. Sounds like me. So now that my interest is more outside the academic and I'm really deep into it, I mean, let's be honest. I see it as a significantly viable platform. Okay, a significantly viable platform, defense purposes, for offensive purposes, for hunting, for target shooting, for everything. Okay, so because of that, I see all this stuff. I want to continue the project. I was like, well, I'm going to install the Mototech SCARburator. I'm going to install a different gas regulator, and I'm going to use that for the research, and let's talk about it. Okay, so we're going to get a little technical, and we're going to talk about the apparatus, so strap in. Now, I want to make sure you guys understand something, because I've never seen this talked about ever. Okay, just strap in. There's something important to understand. So if you have a factory SCAR 17, I want you to pull out your gas regulator knob. Okay? Pull it out and look at it. It's easy. If you're looking aft, like toward the weapon, you depress the little detent there and you rotate that knob, that gas regulator knob, clockwise. So the opposite direction so you're rotating it clockwise if you're like staring down the barrel, if you're looking aft at the weapon, if you're looking aft, okay, if the gun's pointing at you, make sure it's unloaded. You depress the detent, rotate the regulator all the way clockwise until you can remove it, okay? And I have one sitting right in front of me here, the one I took out of my 13-inch barrel gas block to install the SCARburator. I have it right here in my hands. Okay, so I want you to look at the holes in the regulator. There's a few, so we're going to talk about them, okay? I want you guys to understand how this works. There are 5 holes. Well, can I say 5? 1, 2, 3, 4, 5. There's technically 6 holes because the back of it's a big opening, but there's 5 holes. Okay? Hole number 1, the front hole. The front of the regulator, right down dead center, axial hole. What is that? That's a vent hole. That's what gas vents out of there. Okay. What's hole number 2 and number 3? Well, those are big holes. You see those big holes in the shaft there? What are those? Well, those are the holes that let gas in from the gas screw. Okay, from the gas port on the barrel. Remember, gas comes through the gas port on the SCAR barrel, through the gas orifice screw. Then where does it go? Well, it goes through one of these 2 holes. Now, why are there 2? Well, these holes are offset radially. They're offset radially because one is used when you are at the 12 o'clock gas setting, which is the adverse setting, and one is used when you are at 10 o'clock, which is the normal setting. Okay? I'll get to that in a second. And people are like, no, I thought that was the suppressed settings. Like, no, it's not. That's the setting that you should be on, and then if you put it at 12 o'clock, that's adverse. Now, I told you there were 5 holes. We just talked about 3. What's hole 4 and hole 5? Those are really small holes. They're tiny. So where are those? Well, those are on the shaft too, like holes 2 and 3, but instead of being distributed radially, these are distributed longitudinally. Okay, that means they're in a line along the length of the part. Okay, that's what longitudinally means. So what are these? Well, these are extra vent holes. Remember, I just got done telling you hole number 1 at the front was a vent hole because it was kind of big. Well, these holes 4 and 5 are also vent holes. They vent easily to atmosphere. They do. But how do they do that? Well, they vent via a little recess in the gas block opening only when you have the regulator set to 10 o'clock. You feel me? So let me recap. And I just said a lot of stuff. And for you, those of you who never used a SCAR, you're like, what is he talking about? I know, I have a point. Just bear with me. Let me recap. So how many settings are there on a stock SCAR 17 gas block? There's 2 settings. Okay? Setting 1, 12 o'clock. The little switch is it pointing at 12 o'clock straight up. That it lets gas through and it vents out the front of the regulator through the center hole. Cool? Cool. Simple. Now what's setting 2? That's when you switch the thing to 10 o'clock. Okay? It lets gas through the same way the other one did, the other setting. It lets gas right out of that gas port through the gas orifice screw into the gas block the same way the other thing did, and it vents out the front of the regulator through the second hole, or the first hole, just like the first setting did. But what else does it do? Well, it vents even more because now you have those 2 small vent holes actuated as well. So what does that mean? What does that mean about the SCAR gas block? That means that setting 2 is not a restrictive setting. It's an additional vent setting, isn't it? Yeah, this is something you never hear people talk about. I dug on the internet, and I looked and searched and looked. And I saw people talking about, yeah, well, there's 2 holes, and one of them is smaller, and you can't tell, but it is, and it looks this, and it does this, and I think it's just, and it, when you turn it, it's gonna let less gas in, and it's a restrictive setting. That's for a silencer, and no, none of that's correct. Look, you can pull it out, dude. Okay, setting 1. Lets gas in and vents. Setting 2, lets gas in 2 and vents more. That's it. So for those of you who didn't understand how a stock, this is on a stock SCAR, dude. For those of you who didn't understand, when you switch to the 10 o'clock setting, which some people call the suppressed setting, that's actually just a bleed off. That's and the normal setting when it's on at 12 o'clock, that bleeds off less. So from a strict interpretation of function, I don't care what the FN manual says, I don't care what your armorer says, and I don't care what FN says, actually. From a strict interpretation of this system, the 12 o'clock setting is your adverse setting, and your 10 o'clock setting is your normal setting. That's it. Done. I don't care what any document says anywhere in the world. I'm telling you the physical function of this system mechanically and pneumatically with regard to combustion byproducts from the weapon system functioning, okay? Independent of silencers, independent of anything. That's how the SCAR works. Okay, cool. So now I'm going to take you through another detour. Okay, I'm zigging, I'm zagging. Follow me. Listen. Remember the superlative arms adjustable gas block that people use on their ARs? The one that can operate in restricted mode or bleed off mode? Pepperidge Farm remembers. That's right. It exists. You've heard me talk about it in the past there for the AR system. Okay, that's not a SCAR thing, it's an AR thing, but just bear with me. So, the SCAR gas regulator never operates in restricted mode like the superlative arms block does on the AR. It doesn't, no. It's a bleed-off regulator. The stock SCAR gas regulator is a bleed-off regulator with only two settings, homie. Partial bleed and more bleed. That's it. That's what it is. The SCAR gas switch is a bleed-off regulator with partial bleed and more bleed. I said it again, just so you get it. Yeah. So that's how a SCAR gas block works. You have two areas of adjustment, the gas orifice screw and the regulator. Okay? Gas comes through the gas port, has to pass through the regulator screw orifice. Now you can change that screw. So that's the first knob you can turn. That's your restriction setting. Then the gas goes into the regulator. You can change the position of the regulator to one of two vent settings, partial vent or more vent. That's the second knob you can turn. Okay? So, in effect, the tuning mechanism of the SCAR gas block is actually more complex than the superlative arms block, isn't it? It's actually more complex than the superlative arms block. In fact, I would view it as superior mechanically. I would view the stock SCAR gas regulating system superior to the superlative arms system. This is why. So, think about it. Think about why. The stock SCAR gas regulator in the SCAR gas block allows you to do both restrictive tuning and bleed-off tuning simultaneously, right? Remember, because you can change the gas orifice screw in the gas block, that's your restrictive tuning, and then you can change the set, you can flip the switch on the regulator, which is your vent setting. You can change both simultaneously, can't you? With the superlative arms gas block on the AR, that bleed-off block, you can use restricted mode, or you can do various degrees of bleed with full open, with no restriction. Right? So it's an either or with the superlative arms block. But with the SCAR, you can restrict with different orifice screws, and for every restriction setting, for every orifice size, for every screw you use, you have two bleed settings. You see the difference? That's right. The SCAR is much more advanced in that way, isn't it? And gas management. Isn't that interesting? I thought that was really interesting. I've never heard anyone say this. So when I saw this, I was like, I bet people will want to know that. So now that you understand the SCAR gas system, and believe me, I'm telling you, I have never, ever seen anyone explain it like this. So I think it's useful. If it's useful to me, so if it's useful to me, it's got to be useful to somebody. That's what I think. That's my whole philosophy about PEW Science. It's like I'm doing the stuff that I want to know and figure out, and it's helping me. So it's got to help other people. And I feel like if I keep doing that, it's gonna work. This whole effort, right? 1 second, I need some water. Okay, so now let's talk about the Mototech SCARburator. You're like, is he going to get to the SCARburator? It's like, yeah, I am, but you had to know all that stuff first. Because if you didn't know all that stuff, the SCARburator would not really make any sense to you at all, and you probably wouldn't understand it as well. Now this is, don't get upset. I know some people are about to lose their minds. It's fine. The SCARburator, and you see this coming, don't you? The SCARburator actually takes away the venting flexibility of your SCAR gas block. Okay? Too bad, so sad. Sorry. Anticlimactic. But that's right, it does. Now, like I told you, when I was describing the holes in the stock gas regulator on the SCAR, that stock gas regulator vents out the front, right? Out of a front hole. SCARburator does that too. Okay? It vents out the front. That's the first thing I asked that Eddie guy at Mototech Engineering. I said, hey, man, before I bought it, I said, hey, or after I bought it, I called him and said, hey, man, hey, Eddie, how does your SCARburator vent, bro? And he's like, oh, right at the front. I was like, oh, like the original one? He's like, yeah. I was like, okay. It's like, cool. Okay, so it's still venting. So he probably, and I haven't used pin gauges to verify, but I would expect that he probably matched the vent hole diameter. I mean, if I were him, I would have done that. I would have expected him to do that. So he does that. Okay, so that's smart. Probably. But the one thing that happens when you put the well, there's a lot of things that happen, but one of the things that happens when you put this with a SCARburator in there, when you pull out your stock gas regulator and you switch it and you switch it to the SCARburator made by Mototech, what happens is you can no longer switch it to 10 o'clock. It just stays at 12 o'clock. There's no switch. It just stays in there. Okay? It doesn't get... So what does that mean? Well, it doesn't allow you to switch. It doesn't have any other holes in it like the stock regulator does. And so instead of allowing you to switch it, instead of allowing you to turn it from 12 o'clock to 10 o'clock like the stock one did and gain more venting, instead of being a bleed-off regulator like the stock gas block, what the SCARburator does is it offers you the opportunity to change the diameter of hole number 2. That's right. The hole that allows gas into the regulator from the orifice screw. The SCARburator has an adjustment knob built into it, and you can turn it clockwise or counterclockwise, and it occludes the gas hole in the regulator, the source hole, the input hole coming from the gas block on its way to the piston. It occludes that hole with a hyperbolic geometry of the adjustment knob. That's a fancy way of saying when you turn the knob clockwise or counterclockwise, the hole gets occluded or blocked by a certain amount. And there are 10 positions, and they're marked. Position 0 is fully closed. Position 10 is fully open. Okay, you understand what this is doing? It's like a worm drive. It's not. No, that's a bad word. Forget I said that. It's not a worm drive. It's like a corkscrew in a way, where when you're turning it, the geometry of his knob shaft is cut almost helical. Okay, he would call it hyperbolic, which it probably is. Remember I said that the other day on the episode. He probably did it. He probably did it like that so that it seems linear, in that the changing area with each position click from 0 to 10. He's trying to make it as linear as possible. You understand? So anyway, that's what you need to know. So in position 10, which is full open, you have the equivalent gas setting of the 12 o'clock position of the SCAR gas regulator. Okay? That's all it is. When you have it open to setting 10, and it's sitting there at 12 o'clock, because it can't move from 12 o'clock, right? But your little your dial knob can't. The dial is at 10. Dial goes from 0 to 10. The dial is at 10, and your SCARburator is installed. You are in the same gas situation you would be in with a stock SCAR gas regulator at the 12 o'clock. The adverse setting. You feel me? So that means the fully open setting of the SCARburator on setting 10 is equivalent to the adverse setting on a stock SCAR. Okay? You no longer have the original 10 o'clock position option. You no longer have the opportunity to vent extra gas. So in that respect, the SCARburator is a step backward from the stock SCAR regulator knob. Okay? Again, this is probably the second thing on this podcast I've said that no one's ever told you before, ever, or at least not made it known on the internet or talked about it. I don't know why no one's talking about this, but the SCARburator is a step backward in that way. Now, knowing this, I installed it. Now, in order to do that, I had to loosen my KDG rail for it to fit. It sucked. So now this is the second strike against the SCARburator in my mind. So what does that do? Well, it both takes away an additional venting option. So automatically, by installing the SCARburator, you've taken away your additional venting option. And so that's one thing. And now it's also, with its adjustment dial, it's longer. So if you have a KDG rail, you have to move your rail to install it. That's right. So what does that mean in practicality? Well, guess what? You can no longer change gas orifice screws if you have a KDG rail with the SCARburator unless you loosen the rail every time. So if you attempt to remove the SCARburator when you have your KDG rail installed, you pull it out, it will pull out almost enough for you to remove your gas orifice screw in your gas block. Almost, but not quite enough. It's one of those, you're like, oh, it's so close. What a dumb thing. And so, so the adjustment knob is a little too long for that rail, for the KDG rail I have, okay? That little pocket. I'm just going to Dremel that thing. I'm sick of that stupid. I'm not going to use an M-lock slot on the front of that thing. I may as well just Dremel it. So, adjustment knob's a little too long. So there you go. Just something you need to know. I mean, this is a test apparatus, so I'm going to cut that rail with a Dremel. And I'm going to notch it, and we're going to be good to go, I think. I don't know. I don't know any machinists local to me, so I think we're just going to do that. I figured you guys need to know that. I know Eddie from Mototech has said this, that, it's no problem. You just loosen your rail. You don't have to take the rail off. Just loosen it, and da-da-da. It's like, well, you got to unscrew stuff. So what's the difference to me? It's like, still, you can do it in the field? So anyway, let's move on. So now I forget which gas orifice screw I have installed right now. See, I told you I was going to forget. I told you, like, at the beginning of this, I told you I was going to forget some stuff because it's been a minute. It's been a week or two. But I do remember the settings on the SCARburator that I used. Okay, when I shot this, because I installed the SCARburator and I actually shot it. So what did I do? What was the first experiment I ran with this thing, with the SCARburator? Well, what I did was I changed the OSS muzzle device with the Surefire beveled spacer shim thing. I took that off the barrel, and I put a CGS Hyperion thread adapter onto the barrel, and I put a Hyperion K on there. Okay, now, something important to note, and something that was fortuitous for me and the weapon. The Hyperion thread adapter was created for this purpose in a way. It indexes on the muzzle of the SCAR. That's right. Big brain hours over at CGS because I tell you what, the shoulder on the SCAR barrel sucks. So it's cool that the Hyperion thread adapter can index right there on the muzzle. So that's very good. That's I give a way more of a warm fuzzy with that. You don't have to use any shims or anything. It's amazing. I love that part. So that's cool. And it doesn't have that much length. So it's cool. And you get like a tapered muzzle on your SCAR, and it's all short. And like, heck yeah, man. It's like, yeah, I'm into that. Now, I didn't just do that because of the adapter. The Hyperion K was one of the first things I wanted to mess with. Okay. What's the first reason? What did I complain about with the OSS HXQD 762 on this gun? The weight, dude. Got a 13-inch barrel. I'm shooting this thing like a carbine. It's awesome. It's 762 NATO. I'm trying to keep weight to a minimum. The SCAR is a pretty light system. The HXQD 762 is heavy. Its muzzle device is kind of heavy. The whole thing's heavy. Guess what? Hyperion K is super light. It's super small and light. It's titanium. And according to the Omega metric, according to the PEW Science Omega metric, it lands in zone 3. That's right. Zone 3. If you remember your zones, your Omega zones, zone 3 is described on my website as minimally affecting function on all but the most gas-sensitive host weapons. That's right. Now, this is Omega 762 Zone 3. Omega 762 zones should be directly applicable to the SCAR 17, right? You guys are all hung up on 556. Well, forget about 556 for right now because we're in 762 land, 762 NATO world, and we're talking about the Omega metric, which the only one you've seen published has been Omega 762, so that's what we're talking about. And the Hyperion K lands in Zone 3. Zone 3, minimally affecting function on all but the most gas-sensitive of the host weapons. So you might be thinking, oh crap, well how sensitive is the SCAR? What does that mean? Oh my god, what's the Hyperion K going to do to the SCAR? How sensitive is the SCAR? Well, I'll tell you exactly how sensitive it is. Well, at least with the SCARburator. Okay. With the gas orifice screw that I had installed for whatever screw that was, I don't remember what I put in there for now. For reliable function unsuppressed, that with no silencer, for reliable function unsuppressed, I had to have the SCARburator on setting 6. Okay, that's 4 settings from full open. That's a function of the gas orifice screw I have installed in the SCAR right now. That has nothing to do with the SCARburator. I'm just telling you. So with that orifice screw, if you know how to SCAR works, so the gas port size, for that gas port size, I had to have the SCARburator on setting 6 for reliable unsuppressed function. Okay? If I had it on setting 5, it might malfunction. If I had, but setting 6 was good. Setting 7, I wouldn't need. So I left it on setting 6 unsuppressed. You feel me? Okay, cool. Now, what happens when I put the Hyperion K on it? Well, I had to have the SCARburator on setting 3. So there you go. That's one data point. Okay, that's one data point for the gas orifice screw I had installed. Okay, so the Hyperion K in Omega 762 Zone 3 on the SCAR 17 with a 13-inch barrel with the gas orifice screw I had installed results in a SCARburator gas setting change of 3 positions from 6 to 3 for weapon function. The flow restriction of the Hyperion K is enough to induce a needed change 3 settings from 6 down to 3. That's all I got right now for that. Okay, one second. You understand? So did the Hyperion K affect function? Yeah, it did. What does that mean? It has flow restriction. Did we know that? We sure did. Did it have a lot of flow restriction? Well, it depends on your definition of a lot. All right, so let's keep going. I'm talking about function, but let's talk about the next step. Because so some of you might be screaming this at your phones, or your computers, or your whatever you're listening to this, in your headphones at the gym. The next step for me is to install a gas orifice screw that has a smaller orifice. Why? Well, I want it to be more restrictive. But why? Well, I want it to be more restrictive such that I need more open SCARburator setting for function. You understand what I want to do here? But unsuppressed. But I don't want to set it to setting 10. You understand? So let's pay attention. If I make it so that the orifice screw is so restrictive that I need setting 10 on the SCARburator for reliable function unsuppressed, that means if the weapon gets super dirty, I would not be able to get more gas impulse, would I? Right? So my plan, this is my harebrained scheme. My plan is to make it so that setting 9 is my top setting. Or maybe 8. Setting 8 or 9 is my top setting. You feel me? So I'll adjust the gas orifice screw size iteratively such that setting 9 is what's required for reliable function unsuppressed. Or setting 8 or 9 is required for reliable function unsuppressed. Okay? So that's going to require loosening the rail. So maybe I can fire the gun without the rail. I don't know how that's going to work. But anyway, I don't know. Anyway, you can see why that's a pain in the butt. That's stupid. Oh, that's why I have to Dremel it. It's like such a shame. It's such a cool rail, but it's like, SCARburator and the KDG did not know each other. You understand? So you understand what I want to do here for the next step. So you understand that now. I want to make sure you guys understand this. For those of you that are following this project and also modifying your SCARs, you understand that now with the SCARburator, you won't have an adverse setting 12 o'clock and a normal setting with venting 10 o'clock. Okay, 12 o'clock is your permanent setting. And if you want more gas than dial 10 gives you, you need to make the screw orifice bigger. Okay, so you need to make setting 8 or 9 your function baseline unsuppressed. That's what I would recommend right now. Now, okay, back to this. I'm going to use the term circle back. We're going to circle back. We're going to circle back to the function of the SCAR with the Hyperion K. Okay, so now remember, unsuppressed, we're at 6 on the SCARburator. Suppressed with the Hyperion K, we're at setting 3. Okay? So how is function different than using the OSS HXQD 762 on the 10 o'clock vented stock gas regulator setting? Talk about changing stuff. You got a flow through silencer, you got extra venting in the gas block, and now I'm like, I got a restricted setting. I got a Hyperion K with more flow restriction than the OSS. What is this apples to apples or not? It's like, it kind of is, kind of isn't. So when I was shooting it, it seemed to be somewhat comparable when it was tuned like that. It seemed to be somewhat comparable, but I couldn't do it side by side like in quick succession because of the involved process of changing the SCARburator. You understand how long it takes because you got to take the rail off. It is not good for testing, dude. It's a pain in the butt because of that rail, the KDG rail. It's like, ugh. And a lot of people are like, oh, it's so easy. It's like, no, when I'm doing this, dude. So yeah, so I don't have recoil difference impressions for you because I'm a human being, and a subjective impression like that, it's hard for me to, it's not like back to back, so it's hard for me to remember. So it's really not reliable. My impression is not significant. It's not, you take it for what it's worth, I guess I would say. Part of me, and this is, and I might get in trouble for saying this, I don't want to speculate too much about what I felt, but part of me feels like the recoil is more harsh with the Hyperion K on that restricted setting, but it could be clouded subjective impression from the fact that I know what non-vented gas impulse is doing. Like it could be that, like you know what I mean? Like I think I know too much. And so I don't know if it's something, I just don't know about, I can't remember everything because it was such a far apart shooting session because I couldn't do it back to back. Right? So, but I can I can tell you something I can quantify. Okay, with the shootability stuff. The debris in the action in the system. I remember, you guys got to understand this. I had run 800 rounds of 7.62 NATO through this gun, suppressed with the OSS silencer, right? Remember I told you that? And with the Hyperion K, immediately this thing was getting dirty, dude, within the first 5 rounds. Blew stuff out of the ejection port, actually. I was like, whoa. Not on me, but I saw it on the side of the gun. I was like, huh. I was like, whoa, what's that? I had forgotten. I had forgotten that suppressed semi-autos get dirty. And remember, this is the SCAR I've been shooting. I hadn't shot this SCAR with the traditional non-flow-through silencer since I got the SCAR. So the SCAR didn't know anything else. I didn't know the SCAR in any other way. The only other time I had shot a SCAR with a silencer was when I had visited OSS last year. Before they had even supported the effort, before they had even contracted with me to do testing. So the only silencer experience I had on the SCAR was with the OSS. So I put this Hyperion K on there, and the gun worked. It was tuned. Went from SCARburator setting 6 to SCARburator setting 3. It worked. But it was different than the OSS. I was like, this is interesting. Now, we got to think about it. Let's talk about technically here. So what's happening? Well, you're still partially venting out of the gas block through the center hole of the SCARburator, right? Just like the stock SCAR gas regulator, the SCARburator does vent out of the front center axial hole. Okay? So it is venting the same as your adverse setting would vent on your stock SCAR. Sure, yeah. But that's not where blowback into the action comes from, right? That's not, that doesn't really matter for that. No, this is, remember, first of all, it's a piston gun. So keep that in mind. Second of all, on both direct impingement and gas piston systems, the majority of the blowback comes down the barrel. That's right. The majority of the blowback comes down the barrel when suppressed. And the SCAR 17 is no different, my friends. It's no different. So, overall impressions, the Hyperion K, it handles good, man. It handles well. It clearly works on the gun, but it does induce flow restriction. It does induce back pressure. Now, is it enough to damage the SCAR? Does the Hyperion? It's in zone 3. It has a low PEW Science Omega 762 metric. It flows pretty quick, but clearly induces flow restriction more than the OSS because the OSS doesn't require a gas setting change, dude. The Hyperion K required 3 clicks of adjustment on the SCARburator. Okay, I'm not saying 3 clicks is a lot. I'm saying it's more than 0 clicks. You understand? So clearly the Hyperion K is inducing more flow restriction than the OSS. Clearly the Omega metric change is warranted and consistent. Okay. For those of you sitting there that, I saw this guy at the forum, AR-15 or ARFCOM, a month ago or 2 months ago, whenever. This guy said this multiple times. He's like, well, the Omega metric hasn't been validated. It's like, bro, it's been validated more than any other metric you've ever used for a gun. It's like, go do it yourself. You can do this test too. Get all the silencers on the chart, put them on an AR-10, and go to town. Okay, adjust your gas block. So yeah, come on, man. Has it not been validated, really? Okay. So yeah, he called it an acoustic perimeter. I'm like, well, we're using pressure. Pressure's pressure, dude. So yeah, I'm serious. I'm being a little facetious right now. Maybe I'm being a little rude, but come on, guys. It's clear that silencers with an ultra low Omega metric have extremely high flow rate. It's clear. It's clear. As the Omega metric climbs, you induce more flow restriction. We've seen it time and time again. Take all the rugged silencers and do a case study with them, for example. That's what the Omega metric. That's how the Omega metric actually came about. If you actually read Research Supplement 640, that's a public article. You can, members and the public can read it. If you read that, we started off. We noticed something. And the rugged rifle silencers were an excellent case study for that, okay? Because they were so simple. And with the minute changes Rugged did, it would just like, it just really isolated variables. And it showed us in the waveforms, and we were like, oh my God, the flow restriction on the AR-10 or the AR-308 is tied directly to the initial slope of the impulse waveforms. Oh my God, this is a metric. Oh my God, we can derive this. And then the Omega metric was born. It applied to every. I mean, it's amazing. It started working with everything. I was like, oh my God, this is working everywhere. And then I put math to it, and the math works too. The units work, everything works so far. I mean, is it perfect? No, it's not perfect, but we're in the process, right? That's part of the SCAR project. So here you go. Here's the first data point with the SCAR that I'm telling you about publicly. The Hyperion K. You know what? Why do it from memory? I'm gonna pull up. Man, how far are we on time? What are we doing? Okay, we're 55 minutes in. No, that's not good. Okay. All right, sound signature reviews. I'm going to pull up the latest 308. It's the fastest way for me to get to this. Okay, 81, that's a Hydrogen L. Okay, cool. Hydrogen L article, figure 8, Omega metric, 762. Okay, so I'm looking at this. Like I said, zone 3, the Hyperion K is in zone 3. Now remember, the back pressure metric Omega, the way I have it plotted in these figures, it's pascals to the -1 times 10. So the unit is 1 over Pascal, and I've multiplied the axis by 10 so you can read it. So you don't really need to worry about that so much as you need to worry about the fact that 0.08 for the Hyperion K is bigger than 0.05 for the HXQD 762. Now, does that necessarily mean that there's some kind of like, the difference is 0.03. The Hyperion K has 0.03 more back pressure than I've heard people say this before. The Hyperion K has 0.03 more back pressure than the HXQD 762. No. It doesn't have 0.03 more back pressure. There's no meaning to that word, to the sentence. What it does mean is that the slope to the maximum positive phase impulse is less steep with the Hyperion K than it is with the HXQD 762, meaning that the impulse accumulation 1 meter left of the muzzle seems to take more time with the Hyperion K than it does with the 762 OSS, which means that it's likely that gas is coming out faster with the OSS. Okay, so that's what the Omega metric means. And I put numbers to it so we could plot it and we could have a parameter. And I put units to it so people could also check the math and derive it. And again, it's been on the website for years for peer review. If you want to, you know what I mean? It's like people complain, like that dealer in Louisiana complain it's not peer reviewed. It's okay. Well, it's like we'll review it then. And I mean, just like HK reviewed the GSL data, a couple weeks ago, right? So, oh crap, did I say that out loud? Yeah, I didn't say that before. Just strike that from the record. So anyway, it doesn't matter. You probably already knew that. So when I'm looking at this chart, zone 1, 2, 3, 4, 5, 6, 7, I picked these zones based on a general understanding of how these silencers typically affect guns. Okay, you can move these zones around. The purpose of the zones is to group it, and I plotted it on a logarithmic scale to illustrate the fact that differences can happen at the bottom of the scale and at the top of the scale. And the differences might not be the same. Okay? And if you plot it linearly, it almost makes it seem like it makes no sense. Okay? When you have a large variability in a parameter, that's why we use the logarithm. Because like if you look, the chart is ranging from 0.02 times 10 to 7. So like your orders of magnitude, right? You're a couple of orders of magnitude across the span of omega. And so that's why it's a logarithmic scale. So we look at this Hyperion K, and we're sitting there and it's like, well, similar to a resonator K. It's a little bit less restrictive than a Salmon S, but it's more restrictive than a Helios QD with a vented end cap. And it's more restrictive than an OSS. And it's more restrictive than a Radiant in the short configuration, which is what, like a baffle or two? 2 baffles or something like that. And it's more restrictive than a Sandman K, which is like barely any baffles and a huge hole in the middle. So it's like, okay, does that pass the smell test? It's like, yeah, it does. It passes the smell test. Is it perfect and 100% correct? Like in all these numbers and the spacing between the numbers, are they 100% correct with regard to weapon function? Well, maybe not. But what we do know is that right now these two data points that we've explored on the Omega chart with the SCAR, on the 13-inch barrel, the HXQD 762 and the Hyperion K, the relationship is holding true in that the Hyperion K is more restrictive and it has a higher Omega. So there you go. Okay, I'm going to close that window. Okay, cool. So I hope that's a real life demonstration of understanding the impact of the Omega metric and what it can mean. Okay? Because the OSS, you don't need to change gas. If at all, I mean, you can probably a little bit, but again, I would have to now change the muzzle device, put it on, yada, yada, yada. But you get the point. Remember when I first described the function with the OSS and I had it on restrictive versus not, or I'm sorry, see, I even made the mistake. And I had it on adverse versus vent. Like there was no like the OSS is like, I love it when you vent more. I don't care if you do, but I love it when you vent more. The gun loved it when you vented more, but it wasn't the silencer changing that. It was the fact that you're venting more with the 10 o'clock setting on the stock block, right? Yeah. So when you look at a 0.03 Omega, should I pull that up again? Okay. Yeah, I didn't finish my thought, so let me pull it up again. Let me go back into that. Sorry, I got distracted. So let me go back to that chart. So if you look at the Omega 762 metric chart and you ask yourself, well, is the Hyperion K restricting flow enough to damage the SCAR? Is a 0.08 Omega 762 metric on that chart, is zone 3? Can a silencer in zone 3 damage the FN SCAR 17? That's a good question, isn't it? Can a silencer in Omega Zone 3 damage the SCAR 17? And so you have that question in your head, right? Now let's think of another question. If a silencer is in Omega Zone 3 and it doesn't damage the SCAR, is that because it's in Omega Zone 3? Or is there something else going on? And conversely, I would ask, if a silencer in Omega Zone 3 does damage the SCAR, is it because it's in Omega Zone 3? Or is it because something else is going on? See? How do we know? Does correlation imply causation? Sometimes. Sometimes not. Sometimes not. So that's a curiosity, and it's really interesting. And here's one of the reasons why I'm bringing this up. If you look at the Omega table, and you see the HXQD 762 at 0.05, the Hyperion K at 0.08, what happens when you get to Zone 4 on the cusp at Zone 3 and 4? What silencer's there? The Dead Air Salmon S. The Salmon S is there. Its Omega metric, its Omega 762 metric is 0.1. So it's more than the Hyperion K. Think, it's a little bit less than the rugged razor, isn't it? SpaghettiOs. And then you get a little bit higher. What do you get? SOCOM 762 RC2. Then what do you get? Trash Panda. Well, then when you get Nomad TI. So in zone 4, you got some heavy hitters, man. You got a Salmon S. You got on the cusp of 3 and 4. You got the Razor, the rugged Razor. You got the SOCOM 762 RC2. And then you got the Trash Panda, and then the Nomad TI coming up there at the end, moving into zone 5, which is definitely more flow restriction. So you got to ask yourself, if you want to look at, like, I guess you could call it anecdotal experience or anecdotal reports, have people broken the SCAR? Have people broken the SCAR with silencers zone 4 and above, or zone 3 and above? We know that people haven't broken the SCAR with an HXQD 762. We're pretty confident in that. And FN has all but confirmed that that's correct. And I have it on good authority that a Hyperion K on a SCAR doesn't tend to break it either. In fact, CGS has used Hyperion Ks on SCARs of various calibers for quite some time. And CGS interfaces with a lot of folks that use the SCAR and not really for consumer use. I'll just say that. Okay? So, I'm pretty comfortable, and now this is a cautious statement. Don't take this as gospel, but tentatively, I would say I'm pretty comfortable extrapolating our current limited experience in the PEW Science SCAR Project to say, in a preliminary fashion, that zone 2 and 3 may be a SCAR 17 safe zone. Possibly. Maybe. With some caveats. If your SCAR is overgassed, it will break. If your SCAR is not tuned for the Hyperion K, I don't know if it's safe. But what I do know is that when tuning the SCAR for the Hyperion K with the SCARburator, it seemed to work. Okay, it seemed to work. Now, the brass was ejecting in the proper location, right? Remember, where do you want gas ejecting with the SCAR? Where's the best place to eject with the SCAR? Well, you want to eject around 4 o'clock. Or like 4:30 or 5. Like here, let me use a better way, a mathematical way to say this. You want your brass to go back at a 45-degree angle from a SCAR. That's how you want ejection to happen. Now, it was doing that when I was shooting the Hyperion K, and I was pleased when it was tuned, right, at gas setting 3 on the SCARburator. But to me, I feel like it was ejecting more forcefully. I was like, I think that brass is flying further, but it's flying at the same angle, but it's going further. I was like, that's weird. Like something was different. I'm telling you, dude. I'm telling you, something was different between using the OSS and the Hyperion K with the SCARburator. Something was different. I couldn't put my finger on it. I was like, what's weird? And I was thinking about this, and this all ties together with the Omega metric and damage to the weapon and like the different silencers. I was thinking about this. Is it the lack of bleed off in the SCARburator? I was thinking about it. I was like, is this due to the different shape of the pressure pulse in the gas block? And when I say shape, in time, pressure over time. Do we have a different impulse load? You understand? Remember, dig deep, guys. Dig deep in your memory banks. Remember what happened with the superlative arms gas block when you went to bleed off mode instead of restricted mode? OG members of PEW Science, remember this. OG listeners to the podcast, followers of mine from many years ago on social media will recall that the bleed off function of the superlative arms gas block can influence the shape of the pressure curve at the at a piston interface or gas tube, whatever. So is that what I'm noticing with the Hyperion K because I'm using the SCARburator? Because I have less bleed. I have less bleed off of the SCARburator, right? Remember? Am I noticing a longer duration positive pressure pulse with less amplitude, but just long? Is it just? Am I taking the pressure pulse and I'm dropping the amplitude and stretching it in time? Am I taking that? Imagine it's a hump. What if I'm flattening the hump and broadening it? Is that what I'm doing? Is that why the brass ejects are on the same angle, but just further, maybe? I don't know, dude. I honestly don't know. So right now, I feel like we do have a path forward with this research apparatus. Okay, I do think we have a path forward. There are a few things to look at. I think first, we need to get high-speed camera views of the bolt. Super high frame rate. I think that's important. I think we also need to get the gas orifice screw size smaller, like I talked about earlier, making setting 8 to 9 with a SCARburator the max. And I think after that, I think we need to catalog different SCARburator function settings with some different silencers, and we need to see how far up on the omega metric chart we can get without breaking something. My poor SCAR. Liebchen. Mein Liebchen. It's Belgian, but I don't know any Belgian words. It's actually, mine's a non-reciprocating charging handle version. I think mine's a USA SCAR. Take that, Belgium. But yeah, this is for science, so we're not going to do a lot of rounds with that, but we're going to figure it out. So that's the plan. We're going to see what happens, guys. I have this window open, so I'm going to open this again. This Omega chart, like, this is what, this was my, like, goal for this, right? Like, what, you think I just, like to look at numbers for fun? I mean, I do, but also, I kind of wanted to make a useful tool for people without having to, like, I don't know, test every silencer on every single weapon in existence, which would be, like, crazy. So what I was thinking, I was like, well, what if I could look at some expedient parameter from the data I already have, create the omega metric, and look at flow restriction that would be meaningful for a system? So what if we're looking at zone 3 and zone 4, zone 2 and zone 4, zone 2 and zone 3 on this chart? And what if it ends up being that you can't safely shoot a SCAR 17 without having a silencer in zone 3 or below, or zone 4 and below? Or you'll eventually break it. Because guess what? On the internet, dude, I searched far and wide to see if I could dig and see people's experience. I started asking people about their experiences with their SCARs. This dude had a SAM NS, a dead air SAM NS, and he broke his SCAR. I'll have to pull it up. I think I saved what he told me. I don't know if he was on Reddit or a forum or whatever, but I had a conversation with this guy. This guy had a SAM NS, and he broke or maybe I didn't have a conversation with this guy, or I saw this conversation with this guy. He had a SAM NS on a SCAR 17, and he tuned it. I don't remember how he tuned it. I think he was just with the gas orifice screw, so I don't know if he was using the vent mode at the 10 o'clock setting and tuning his with his screw, or if he was using the 12 o'clock setting, which is less venting with the stock regulator, and then he was changing his screw. But either way, the screws that he used, he found that he broke his bolt carrier with the SAM NS. Does that mean... And from what I remember, I think he said something like, well, I wanted my thing to function unsuppressed on the normal setting, and I wanted it to not function unsuppressed on the vent setting. So I changed the thing, and I'm thinking to myself, guys, you are looking at this all wrong. Why are you tuning like that? Just don't. It's like, okay, like, tune it so it works with if you have a stock regulator in your SCAR, turn it to 10 o'clock. That's your setting to tune your gas screw with. The only time you should flip that to 12 o'clock is for adverse conditions when you can't cycle through the muck. Okay? If you want to shoot your SCAR unsuppressed and suppressed, get a different gun. Or an OSS. Because I'm telling you, going above Omega Zone, because remember, HXQD762 was on the cusp of Omega Zone 1 and 2. Going above the flow restriction of an OSS and wanting your SCAR to function suppressed and unsuppressed, like with the stock gas regulator is a recipe for breaking your apparatus, breaking your weapon system. And I want to think, and I hope this is true. And I don't hope this is true for Dead Air, and I don't hope this is true for PEW Science, and I don't hope it's true for the Omega Metric, but I hope this is true for SCAR owners. I hope it's true that guy that broke his SCAR with the SAM NS messed up. Because if the SAM NS properly tuned on a SCAR 17 breaks the SCAR 17, what that means is that you're not okay to use any silencer outside of Omega Zone 3 and above with a SCAR 17. And I don't think that's true, because the SOCOM 762 RC2 reportedly works great with the SCAR, and that has a 0.12 Omega metric. Omega 762 metric. You feel me? You understand why that's why I think it's I think it's user error. And sir, I doubt you're listening to this, but if you are, I'm not making fun of you. I'm not talking down you. But I do believe if you broke your SCAR 17 with a SAM NS, I believe you might have made a mistake. Not in thinking that you broke it, but in what in how you implemented the system. In how you suppressed the weapon. I think you tuned incorrectly and you flew too close to the sun, possibly, not understanding it. You might not understand how the SCAR worked, and that's okay. Not everyone does. Now, I hope that's true. Because if it's not, and the SAM NS does break the SCAR, and the SOCOM 762 RC2 can break the SCAR, that means that there's something else happening, which I think I understand, and that also means that it's a fatigue problem, and that also means that we have a big problem with this gun. And I think I'm a little bit, I know I'm behind FN with their internal R&D, but I'm catching up. And I think that I'm going to figure this out. So yeah, that's where we're sitting right now. I'm just looking at this Omega chart, and hey guys, guess what I got? I got a SOCOM 762 RC. Like I have an RC2. I got an RC. Isn't that cool? Yeah, so I'm gonna see what that does too. Isn't that cool? I had never used one of those. So it's like the RC1. I guess it's an RC, not an RC1, but it's an RC. So now I have the RC2 and the RC. So I'm gonna mess with that. So yeah. So this is interesting. That's where we're sitting. I'm just looking at this chart again to see if I'm forgetting any other silencer that has been used with the SCAR 17 a lot. Like for example, the Omega, the Silencer Co. Omega at 0.33 Omega metric. That's funny. It breaks SCARs. So there's that. First gen Nomad has less flow restriction. The Rugged Surge in short configuration has less flow restriction. You got the Optimus, you got the Harvester, you got the R30 Vented, which definitely has lower flow restriction. Anthem K, Banish 30 Short, Vox S, the Radiant. Oh, guys, remember the Rugged Radiant in this long configuration? That was one of the inspirations for the Omega metric, because if you take a Rugged Radiant in its long configuration, it has a Omega metric of 0.19, putting it into Omega Zone 4. Well, you know how similar it is to the Rugged Surge in the short configuration, right? The Rugged Surge in its short configuration and the Rugged Radiant in its long configuration are very similar in sound suppression. But one of the things that Rugged did was the way the Radiant is designed, the flow rate's higher. Okay? Guess what? It dropped the Omega metric from Zone 5 with a surge in the short configuration to Zone 4. The Radiant to Zone 4. Guess what? I can tell you right now, without testing that on the SCAR, that's real, because it happens on my AR308. The Superlative Arms gas block used a different setting with those two silencers. So that's another validation case of the Omega metric. Okay, that's actually tied in too. Like when you look at the Hyperion K and the Helios QD, the Hyperion K and the HX QD 762, they're like not super far apart, but they're kind of close on the chart, and they have a difference. And then you look at the Surge in the short configuration and the Radiant in its long configuration, and they're kind of close on the chart, and they still have a difference. See, so this has meaning, you see. So then you go up to a Nomad L, and you're like, SpaghettiOs. Don't put that on your SCAR. You understand? Okay, so that's where we're sitting. I can talk about this all day. I got to be careful. I'm going to run away with it. Okay, let me close that. Okay, so that's the plan. Oh, okay, last thing I'll say about the SCAR. This topic's really long. Oh my God, this is still the first topic? Oh, shoot. Oh my God, first topic is an hour and 20 minutes. What have I done? Okay, last thing I'll say about the SCAR. I put a thermal clip-on on it. I went off the deep end. I don't think we have a lot of time in this episode, but okay, I'll touch on it in topic 3. Okay, topic 2 at a time of 1 hour, 20 minutes, and 40 seconds. Let me get some water. This is going off the rails. I was going to finish this podcast early today. There went that idea. Topic 2, new sound signature review this week? Yes. Am I excited for this? Boy, howdy. Big things. I think this will be disruptive. Buckle up. Oh, people are going to get mad at me. Okay, it's a big deal. Now, I'm going to bring something back you haven't seen in a minute. And I want you to brace yourself. And none of you are going to guess, dude. None of you are going to guess, so relax. Just relax, bro. But what you do need to get is your thinking caps. You need to get your thinking caps on because the data analysis that's coming this week is going to shake things up in a big way, I think. And I'm excited. I'm excited because it's exciting for the manufacturer and it's exciting for PEW Science. So we have a lot of excitement. Step into a Slim Jim. Oh, yeah. I love Randy Savage. He's funny. But for years, really, let's get serious. I'm really tired. For years, there have been people who doubt the PEW Science effort. Those numbers are dwindling, and soon they will dwindle further. This week, in fact, I believe that to be true. The value of PEW Science testing and analysis is now undeniable. Before PEW Science, if you were to ask gun folks questions about silencers, nobody understood surefire rifle silencers and their mounts, dude. No one understood that. Nobody really understood silencer back pressure. Nobody understood hearing damage risk. Nobody understood a variety of silencer technical factors. Okay? All these technical factors that have been highlighted in the articles, people weren't understanding this. Not to mention the unsuppressed gunshot phenomena no one talked about that's been presented multiple times now. None of that was clearly understood by the general public or industry at large. And now it is. You feel me? Now it is. Okay? All that stuff we just talked about with the Omega metric, that's novel, bro. That is novel. That is new. No one was talking about that at all. Okay? And now they are. Because it's working. So this week, we're going to add another thing that has actually already been shown by PEW Science, but people haven't talked about it much. It's something some of you have seen and experienced, but you couldn't quite put your finger on it, could you? You couldn't quite put your finger on it. Buckle up. Because the system that's tested and presented this week is going to highlight behavior in a regime that no one's thinking about right now. And it's one of the most important regimes in suppressed small arms, and it's one that is of interest to many of you. It is, that's right. Strap in, get ready, protect your feelings, because a lot of feelings are going to be hurt this week, and the people that learn from it will be rewarded. Okay? The people that freak out and cry will probably just do that, as always, and we can't help those people. Okay? But I'm excited. A whole new research arc and gauntlet is being thrown down, so let's bring it. That's right. That's all I'm going to say about that. I'm excited. PEW Science. Topic 3 at a time of 1 hour, 24 minutes, and 14 seconds. See, we're going to get back on track here. Topic 3, thermal sights in you. How to spend more money than you thought you would and not be completely upset necessarily. Not cheap, no. If you're thinking about getting to the thermal game and you are not prepared to drop several $1,000s, just don't. Okay? Bet you didn't think I was going to say that. No, just don't. The technology requires that you spend money. And to get enjoyment, utility, and good use out of the technology, you will spend thousands of dollars. And if you don't want to spend thousands of dollars, that's fine, of course. And you can use digital night vision and stuff like that. And there are some neat options. And if you want to hunt or kill at night or things like that, digital night vision can actually be really cool. And that is outside the scope of this current topic. But yeah, you can go wild with that stuff on a budget, man. If you let me know if you're interested in digital night vision, I can tell you some stuff to use, and you'd be like, "Whoa, that only costs that much?" I'm like, "Exactly, dude. Exactly. Is it as capable? No, but can it do a lot? Yeah. Can you be a murderer? Straight up. Now, a couple things. Thermal is not night vision. Okay. The reason we don't call it night vision is because it's not necessarily for use at night. That's right. I mean, you can use it at night if you want, but you can also use it during the day. You can. And the reason you can do both is because it doesn't use visible light. That's right. It's letting you see a visual representation of a different part of the electromagnetic spectrum. You are seeing long wave infrared. That's right. You are seeing heat radiation. More specifically, in a certain spectrum, okay? And so you can't see through glass because that material will reflect waves in this particular spectrum, okay? But you can see through some other materials that are opaque, and you can see through fog and smoke pretty well. And you can see things without influence of visible light. So, yes, that means you can see heat signatures in total darkness with no illumination at all. Or you can see them on a bright sunny day outside too. That's right. That's the beauty of thermal imaging. Okay, infrared thermography, if you want to call it that. Okay, so now this is just an introductory discussion. We're not going to get into shortwave infrared, anything like that. I'm not going to get super technical yet, but I want you to know the basics. I promised I would talk to you guys about this stuff, and a lot of you guys know this stuff, but many of you don't. So basically, a thermal device is a very expensive digital camera that uses expensive germanium glass and a thermal sensor to translate thermal radiation into electrical signals that are displayed on a screen as a picture. That's all it is at a basic level. Okay, there's a lot more complex things to go into it, but that's at a basic level what it is. You view the screen. You are looking at a screen. It is a camera. You understand? They are not, thermals they're not light amplification devices like night vision. It's not that. They're cameras with fancy glass and sensor arrays. A thermal weapon sight is more similar to digital night vision than it is to night vision. Okay? It's true. Now, let's talk about the different types. There's a few different types of ways to use thermal. And you should know, you can use a handheld spotter, a handheld spotting device. These are usually the most economical. I think I've talked about this before. I've shown you mine a bunch. I use a Helion XP50. They don't have to be recoil rated, because you're not putting them on a weapon, right? So that allows them to be cheaper. And therefore they can be larger. And they can be heavier, which also allows them to be cheaper. And they're portable. And they're easy to hold up to your face, which makes them convenient. That's cool. And the learning curve is less steep for folks. And even though there's a learning curve with all thermal, you just think about that. Just keep that in mind. So that's a cool category. And then another thing, you can use a dedicated thermal weapon sight. You can do that too. And they're a lot like the handheld devices, except they mount to a weapon. And they have sighting features, like crosshairs and stuff, right? Like reticles. They're more resilient. Some handhelds can be weapon sights. Okay? And all weapon sights can be handhelds. But not all handhelds can be weapon sights. Yeah, you're right. You understand? Okay. And then also you can go kick it up a notch here, and you can go thermal clip-on. Yeah. Clip-ons function with the day optic. Yeah. So instead of being a dedicated sight, they function with your day optic, and these are probably the most expensive. These are probably the most expensive and complicated thermal sighting systems typically because they have to do things that a handheld typically doesn't have to do, and that a dedicated thermal weapon sight doesn't necessarily have to do either. Okay, so yes, so sure, there are dedicated sights that are very expensive. Like a dedicated thermal weapon sight, there's some really expensive, crazy ones. But a good clip-on, I mean, it's usually comparable in price to a dedicated thermal weapon sight, if not more expensive. And many times there are significant limitations to the clip-on. It's just, they get really complicated, but that's another type of system. And then the last thing I'll say about the categories here, there's also helmet-mounted systems, and so that's just a newer thing, relatively in the past decade or so. They're really coming to popularity. They're very small, and some of them can be handhelds too, as you can imagine, right? If you can put on a helmet, you can certainly hold it in your hand. And and you know what? Some of them can be dedicated weapon sights, and some can be clip-ons. It's just all about size and weight, isn't it? With a helmet thing, yeah. So not many helmet-mounted units can do all of this well, as you can imagine. Okay, this is where you start to climb heavily into price. This is you climb significantly into price when you get into this stuff. And so when you become a jack of all trades and you try to be a master in more than one category, like more than one of these categories, you got to pay to play. So then your cost is rising rapidly, exponentially. So those are the four main categories. Okay, those are the handhelds, the dedicated thermal weapon sights, the clip-ons, and the helmet mounted. Those are the four categories. And there are others, though. There are others, but we're going to stick to these four. Okay, for now. 1 second. Yeah, so by and large, the best way, this is my opinion, the best way I think to start in a thermal game is to get either a handheld spotter or a dedicated thermal weapon sight. That's just my opinion. These two things are going to give you the most capability right away. That's my recommendation. With a handheld spotter, you can find things to engage with faster. Faster than you ever thought possible. You're going to be able to spot stuff that's alive. That to be clear, when we're talking about thermal, we're talking about being the predator. Okay, we're talking about murdering things. We're talking about premeditated murder of animals. Okay, mostly. I mean, I guess you could use it for defense too, for against people, but you can, of course. But you're going to get the most. You're probably going to get the most use out of murdering animals with thermal. I would think, unless of course you're listening to this and you're in the military, which maybe you're using it in combat. That's a little bit different, or maybe you're law enforcement. That's different too. But I know we have a lot of military and law enforcement listening. That's awesome. For all you civilians out there, you are most likely engaging animals with thermal most of the time. I hope you're not in defense situations all the time with thermal as a consumer. God help you. Also, you don't have to use thermal for murder. You can also use it for like finding like heat leaks in insulation of your house and stuff like that. It's cool. Yeah, there's all kinds of stuff you can do with thermal, but which you will quickly become aware of once you get one. But yeah, so you're going to be able to engage stuff faster than you ever thought possible. Faster than you ever thought possible with thermal, and if you have a handheld, for example, and you can engage. When you do engage, you can do it with a variety of options. If it's during the night, you could use red light to shoot with your day optic. If you spot it with thermal first, the thermal spotting will have given you a significant time advantage. Typically, not always, but it can. And I've done it. I used to hunt like that. I used to hunt. Well, before I had thermal, I hunted with I just hunted with red light, like to spot and stalk and shoot. And then eventually, I got a handheld thermal spotter, and then I used that to find stuff, and then I killed it with red light. Yeah, it's cool. Now, if you get a dedicated thermal weapon sight, which you could get instead of a handheld or both, then you put that on your gun, and now you can spot just like you could with the handheld when it's on your gun there, but then you got to use your weapon to spot. So that means you got to sweep your muzzle over everything to see stuff, and that's not always the best. And it's like heavier because it's on a gun. You're like, I wish it was light and like separate. So yeah. So that it really means that usually people prefer to have both a spotter and a weapon sight. You can have a quick detach where you detach it and you spot, and then when you're ready to shoot, you clip it on, or you put on the QD mount. You can do that too, but it's all about what you're willing to do and what you're willing to buy. So there's that. But those are the two things. Those are the two things that I think most people that actually use thermal for killing use all the time. Most people that I know that use thermal for killing, and I know quite a bit of the people, including myself, I think most of the time they're using a handheld spotter or a thermal weapon sight or both. Those are the two things. Now the next two things that we talked about, those are, I think, I hold these next two things as significant luxury items. And I think, not that all thermal's not, but these are pretty significant. And I think people think they need these next two things, but but most of these people have seldom actually used thermal to kill things. And I think, unless they're in the military doing it, so I don't think many times people actually do need these things, but they are cool. For example, a thermal clip-on, they're awesome. They're so awesome, dude. Because they go out in front of your day optic, but they're usually only like 1x, like unity magnification, right? Or maybe they're even demagged. They're less than 1x. And why? That's so they can work with the day scope. Because they're filling a specialized role. You're zooming in on a screen, right, with your day optic. So you need a very high quality day optic. You need a very high quality day optic glass and a good mount system with an exceptionally good clip-on to actually enjoy using a clip-on. Okay? And furthermore, if you have a lot of magnification in your scope, you're going to be paying a lot of money for something that works well, dude. Like to get a really good long range clip-on, thermal clip-on, you're spending so much money, dude. It's not even funny. Clip-ons are typically more practical for a lot of people with low magnification, like a low variable power optic, like the LVPOs that I recently have gotten into after my Razor broke from Vortex. That thing sucks. At least mine did. My reticle broke. So people with these, like, I use the Night Force now. I don't mess with the Vortex stuff. I use the Night Force Attacker, and I love that thing. That's a really good optic for this. You can actually use a clip-on with a red dot or a holographic sight if you put some mag behind them. If you put like a magnifier behind those, you can do that too. If you have poor light transmission through your day optics, a clip-on is not going to be as awesome. It's just not. Also, a clip-on is going to weigh more. It's going to weigh more because you have your day optic too. So your total package is going to be heavier. I would say a dedicated thermal weapon sight is lighter than a day optic plus a clip-on. Like, unless you're talking about some very like niche cases where it's like, something hot, you have some kind of crazy high speed system or something. But yeah, I'd say where a clip-on shines is what's really cool about it, and something I never thought I would use one, honestly, but I'm starting to mess with one. Where it shines is using your awesome day optic setup that you love so much, and then transitioning to thermal really fast if you have that type of system. I think that's awesome, but they get expensive, dude. Okay, and we can talk about that later, but yeah. So, and then finally, I was gonna say about the helmet stuff. The helmet mounted stuff. It used to be super exotic, right? But it's becoming less so now. It's becoming less exotic now, and you can get into helmet-mounted thermal fairly economically. Well, for thermal at least. Cheap for thermal, right? Like only a couple grand. You spend a couple grand, you can actually get into it. And FLIR, and it's funny, the FLIR is the brand name that, it's funny because the acronym was always forward-looking infrared, right? But FLIR makes a helmet-mounted thermal called the Breach. It's not really that great, But it does function. It does function, and I'm telling you, for detecting things that are alive, thermal will almost always beat night vision, even with a breach, dude. You're not all the time, but most of the time, you're going to detect stuff way faster. And for that, I think the breach can be good. It's super small and light, but the image quality and the resolution isn't super awesome. So know that going in. Go talk to my bros at Goblin Tactical. They have an Instagram called Goblin Tactical. Those guys are like really good thermal night hunters, and they use a lot of helmet mounted thermal. They're a pretty small organization, but I'm sure they'll answer your questions. One second. If you want some real good use case stuff for some guys who have been like slumming it forever and then like gradually like built themselves up to like do more stuff at night, like on a budget, they're cool dudes. Now, you can step up to some very exotic and expensive helmet mounted options. There is an option from Trijicon called the Skeet. Yes, it's called the Skeet. Skeeter. Some people call it the Skeeter. Skeet IRX. The field of view is incredible. And many people believe it to be one of the best, if not the best, helmet-mounted thermal options. Now, the thing about it is it's sort of relegated to doing that one thing well. I mean, it does other stuff too. But you're basically going to be spending the money of a nice used car. And so there's that. And then now there are options like the Pixels on Target Voodoo S that also function extremely well as a clip-on and a spotter. I'm using a Voodoo S on the SCAR right now. I'm gonna let you know how that goes. I actually have a photo of it on the gun. I'm gonna put that up for the podcast. This has escalated quickly, guys. It's fine. I love that rifle. Treat yourself. You know what I'm saying? So yeah. So those are the overall thermal categories. This is just an introductory discussion. I hope this helps people. This is just, man, I got a lot of requests to do this, so that's why I'm talking about it. And so those are the overall thermal categories and some basic things to think about for now. Okay, and so you're gonna when you look in the thermal space, you're gonna see brands like Pulsar, Envision, iRay, Trijicon, FLIR, AGM. You're gonna see a lot of different ones. Pixels on Target. That's one I just told you about. You just need to know some of these companies are Chinese. Okay? Now, a lot of people like to buy the Chinese-made stuff because they save some money, sometimes a lot of money, and some of the units are extremely capable. They are. However, they are Chinese. And look, no offense to any... I don't know if anyone that lives in China is listening to this podcast. I somehow doubt you are, but if you are, thank you for listening. I appreciate it. That being said, hey man, it's your money, your philosophy, dude. Like if you want to buy stuff made in China, like that's you, dude. You do you, man. But I'm trying not to do that as much. I just want to highlight as I record this podcast using many things that have come from China. I am telling you, we are supporting an oppressive communist regime by using Chinese goods. Okay, we are. That's how it is. I mean, I'm pretty sure the microphone I'm talking into was made in China. Maybe not. I don't know. Malaysia. I don't know where it's made. I haven't looked, but yeah, I know it's something that we deal with as consumers in the United States. China is really good at making stuff. They make a lot of stuff. We import a lot of stuff from them. A lot of American companies use China for manufacturing to remain cost competitive. I do understand the reality, and I understand the pragmatic nature of consumer purchases based on cost. But I didn't want to talk about thermal without talking about the fact that a lot of it's made in China. And when I said iRay, they say iRay USA or InfoRay or InfiniRay, whatever it stands for. I forget. Dude, that's China. So the Pulsar stuff is not made in America, but it's made in Europe. You feel me? So I've actually met some of their engineers from Lithuania, so they're cool. So yeah, I hope this helps. I can talk about this all day too. I hope that's a good introductory discussion to thermal. And please let me know if you have any questions. And again, oh yeah, since we have a new sponsor, High-End Armament Technology, you guys should call Robert if you want to buy a thermal. I mean, he'll probably be able to get you the coolest stuff ever. So that's awesome. So yeah, all right, let's pivot to topic 4 at a time of 1 hour, 45 minutes, and 14 seconds. Thank you for support. I do mean it. Direct feedback has indicated that PEW Science is doing some good. I see it every day. It warms my heart, and the effort's working. And I keep saying it because it keeps holding true, and I love it. And your support is fueling this, man. And it's gracious. It's gracious support. It's tenacious support. It's heartfelt, and it's aggressive, which I like, because I guess it's because I'm an aggressive person. I really am. I'm aggressively hungry for knowledge and truth. And I'm noticing a welcome trend of people helping others. I really love that, because that's what I like. So it makes me smile. So I like doing. So when I see other people do it, I'm like, oh, dude, that's awesome. It's great to see it. I think folks are getting it now. I think a lot of people who have learned a great deal of technical performance information from the research, I think now they take it upon themselves to educate others. Yeah, and we've essentially created little depots of knowledge, right? This little knowledge depots throughout the community. It's awesome, man. It's gracious folks who want to help people truly understand their suppressed small arm weapon systems. That's how I would define it. It's awesome. So yeah, man, several of you have joined recently. I am working my way through those emails, and I will send you all a welcome email soon. I'm sorry, I'm a little behind on that. I think most of your specific inquiries have been addressed. So if you have been left hanging for a while, please send me a reminder. I may have missed you, okay? But that doesn't mean I forgot you. All right? Okay. So please stay tuned this week, guys, for some quite excellent data that is quite exciting for both PEW Science and the manufacturer, just because of what it shows and I think what the potential it shows. I think we're just scratching the surface with some of this stuff, and it warms my heart to be able to show it to you, show it to the world. Okay? So stay tuned for that very soon, and I will talk to you folks next week. Okay, bye.